subtopic 10.3 Normal Distribution. Learning outcomes. At the end of this lesson, students should be able to identify the normal distribution, standardize the normal random variable, determine the mean and variance of the normal distribution problems, and also use the normal distribution to solve related problems. Normal distribution denoted by x tilde and mu sigma square. The normal distribution is a continuous, symmetric, bell-shaped distribution of a variable. The mean, median and mode are equal and located at the center of the distribution. The normal probability distribution has following characteristics. The first one is the total area under the curve is 1, which means the shaded region, the area under the curve is equal to 1. Then the curve is symmetric about the mean. The two tails of the curve extend indefinitely. If a continuous random variable has a normal distribution with mean mu and standard deviation sigma, that's why it is denoted by x tilde and mu sigma square. The normal distribution with mean equal to 0 and standard deviation equal to 1 is called the standard normal distribution, and the standard normal table can be used to find the area under the standard normal curve. The table that will be used is more than or equal to standard normal table, which is probability z greater than equal to z. It is important to know that probability of z greater than a, the shaded region looks like this, is actually equal to the shaded region for probability z less than negative a, which is like this. In order to standardize a normal random variable x to a standard normal random variable z, we are going to use this formula, z equal to x minus mu, which is the mean, and then divide with sigma, standard deviation. Note that for normal distribution, probability x greater than equal to a is equal to probability x greater than a. Probability x less than equal to a is equal to probability x less than a, and probability x from a to b is equal to between a and b. This is because normal distribution lies under continuous random variable. So for continuous random variable, the equal sign doesn't matter. Example 16. If x tilde normal for 9, find each of the following using the standard normal table. First of all, we need to know that if our mu does not equal to 0 and sigma does not equal to 1, we need to standardize our x to z first. To standardize, we are going to use this formula that was stated above. So the first step is to identify the mean and sigma. So given mu, which is mean, equal to 4, variance equal to 9. So our mu is equal to 4, whereas sigma is actually equal to 3. So the first step to find the probability for normal distribution is to standardize. First step, standardize. So how to standardize? We change from x to z. So our x, which is 8, we have to minus it with our mu, which is 4, and then divide by our sigma, which is 3, and then calculate. Give your answer in 2 decimal places, because we can only take a look at the standard normal table up to 2 decimal places. So it will be 1.33, 2 decimal places. Next, the second step is to sketch the bell shape. Bell shape looks like this. This is our bell shape. In the middle of it is for z equal to 0. So if our z is positive, it's going to be situated on the right side, whereas if our z is negative, it's going to be situated on the left side. So since our z here is positive, 1.33, it's going to be situated on the right. Next, I'm going to shade the region. To shade the region, since the probability is z greater than equal, if it is greater than equal, the shaded region will go to the right. So the shaded region will look like this. Next, the third step. The third step is to identify whether we need to put it 1 minus or not. If we shaded the middle part of our bell shape, for example, our bell shape looks like this, and then we shaded the middle part, we need to put it 1 minus this value. But since we didn't shade the middle part of our bell shape for this example, so we didn't need to do this. We doesn't have to put the 1 minus. Instead, we just put it for probability z and greater than equal to 1.33. Right? Doesn't need to put the 1 minus since we didn't shade the middle part of our bell shape. So just take this value, z greater than equal to 1.33. And then for the last part, we are going to look at the standard normal table. Standard normal table. So to take a look at the standard normal table and find the value for 1.33. First, you need to find the 1.3 first, which is on your left side here, 1.3. And then for the second decimal, it's going to be up there. So for 1.33, the value is here, which is 0.0918. 0.0918. So there are 4 steps to find the probability for normal distribution. B, probability x less than 2. So we have 4 steps that we need to follow. The first one is to standardize, which means we need to change from x to z. So our x minus mu, which is 4, and then divide by sigma. Give your answer in 2 decimal places. Next step, bell shape. 0 would be in the middle, negative 0.67 would be on the left side. Right, so since we would like to find the probability for z less than, so the shaded region will go on the left. So here is the shaded region. Then we need to identify whether we need to put 1 minus or not. If we shaded the middle part of our bell shape, we need to put 1 minus, but since we are not doing that for this example, doesn't need to put 1 minus, so we just take probability for z greater than 0.67. For during the third step, it's always going to be z greater than or z greater than equal in order to look at the standard normal table. Right? So if you wonder why probability for z less than negative 0.67 is equal to probability for z greater than 0.67, we actually take a look at this. We already know that probability for z greater than a, which is this part, is actually equal to probability for z less than negative a, which is this part. So we can look here that the area for the shaded region is equally the same. So that's why the probability for z less than negative 0.67 is actually equal to probability for z greater than 0.67. Or just simply put it greater than and take the value here but make it positive in order to use the standard normal table. And then the last step is to take a look at the standard normal table for 0.67. So take a look at 0.6 here, and then the second decimal would be up there, 0.07. So here is the value, 0.2514. 0.2514. C, probability for x less than equal to 5. So the first step is to standardize like this, and then we get the value, give your answer into decimal places. So we have probability for z less than equal to 0.33. And then the second step is to sketch the bell shape. And since our probability that we like to find is z less than equal, which means it goes to the left. So the shaded region will be on the left side of 0.33. That is our second step. And then the third step, we need to identify whether we need to put 1 minus or not. As I told you earlier, if we shaded the middle part of our bell shape, that is happening here, we shaded the middle part, we shaded fully the middle part, so we need to put 1 minus. And then probability z greater than, or since we take a look here, we have less than equal, so I put equal here to make it balance, right? And then just take the value up here, which is 0.33, and then go to the last step, which is to take a look at the standard normal table. So if you take a look at the standard normal table, you're going to get the value is 0.3707, which will be equal to 0.6293. So if you wonder why we need to put it 1 minus probability z greater than equal to 0.33, so 1 means the total area under the bell shape. And we don't want this part here, which is the area for z greater than 0.33. That's why we need to put it minus here. D, probability x greater than equal to 3. As usual, the first step is to standardize. Give your answer into decimal places. Second step is to sketch the bell shape. Since our z is negative, it is situated on the left. And then z greater than equal means shaded region goes to the right. The third step, identify whether we need to put 1 minus or not. So here, obviously, since we shaded fully the middle part of our bell shape, so we need to put it 1 minus. 1 minus, and always z greater than or greater than equal. Right? And then take the value up here, but just take the positive one, which is 0.33. So that is our third step. And then take a look at the standard normal table for z greater than equal to 0.33, which will give us the value of 0.3707. So finally, we're going to get 0.6293. E, 4 to 6, as usual, the first one is to standardize. But since we have two values of x, we need to standardize both. Minus mu divided by sigma, change x to z, minus mu over sigma. Give your answer into decimal places. Second step, bell shape. 0 in the middle, 0.67 on the right side. So from 0 to 0.67 in between. Right? Third step, we need to identify whether we need to put 1 minus or not. So since we didn't fully shaded the middle part of the bell shape, if we shaded the middle part, we need to put 1 minus in the third step. But since we didn't shade it fully, the middle part for our bell shape, so doesn't need to put 1 minus. Instead, we're going to take probability for z greater than equal to 0, which is this value here, and then minus with probability for z greater than equal to 0.67. This is because when we calculate the probability for z greater than equal to 0, we're going to get the total area from 0 until infinity, and then we don't want this part. This part is for z greater than 0.67. So that's why we have to put it like that. Right? So take a look for the last step, take a look at the standard normal table, 0 and 0.67. So for 0, it means here like 0.00, which is 0.5, and then minus 0.67. 0.67 means 0.6, and then for the second decimal up there, 0.67 is 0.2514. Calculate and you get the answer. As usual, standardize. Give your answer into decimal. Second step, bell. Both negative, -1, negative 0.33. That is our shaded region. Doesn't need to put 1 minus since we didn't fully shaded the middle part of our bell shape. So we just take one of the value minus the other value. So it's going to be probability for z greater than 0.33, doesn't need to put the negative one, and then minus with probability for z greater than 1. It shouldn't be the other way around, because if we take a look at the standard normal table, the probability for z greater than 0.33 is 0.3707. That is for probability for z greater than 0.33. Whereas the probability for z greater than 1, which is 1.00, is equal to 0.1587. The probability must not be negative, so we need to minus the bigger value minus the smaller one. So that's why we take the z greater than 0.33 minus with z greater than 1, so that our probability wouldn't be negative. So the last step, bigger one minus the smaller one. Calculate to get the answer. G probability from 2 to 5. As usual, standardize, sketch the bell shape, and then the third step, identify whether we need to put 1 minus or not. So here, since we shaded fully the middle part of our bell shape, so we need to put it 1 minus, and then minus both the values here. So it should be minus with probability Z greater than 0.33 and also minus with probability Z greater than 0.67. Don't forget, at the third step, it's always Z greater than or Z greater than equal. I'm going to put equal here since the question has equal sign. Here also equal. Then the last step, read from the standard normal table. And calculate to get the answer. Next, H, we're given modulus. So we need to decode it first, separate it into 2. So we're going to have one of the value is negative and the other one is positive. And then rearrange until we have X in the middle. So you -2 plus 4 and also 2 plus 4. So 2 less than equal to X less than equal to 6. After that, only after that, we're going to follow the 4 steps to find the probability for standard normal distribution. So the first one is to standardize. Make sure give your answer in 2 decimal places. Second step, bell shape. One of it is negative. The other one is positive. In between. Third step, identify whether we need to put 1 minus or not. So since we shaded fully the middle part of our bell shape, we need to put it 1 minus and then minus the 2 values here. So Z greater than 0.67 and also Z greater than 0.67. Or we could write it as 2 multiply with 0 Z greater than 0.67. So for the last step, it's going to be 1 minus 2 and then multiply with 0.2514, which will give us the value of 0.4972. As usual, the first step is to standardize, change from X to Z. So our X minus mu divided by sigma. Second step, bell shape. But since our Z is unknown, so I'm going to sketch 2 different bell shape to decide which one is correct. So I test one of the value, I put it on the left side, and the other one I try to put it on the right side. Since our probability is for Z greater than equal, mean the shaded region who goes to the right. Goes to the right from that value. And then we need to check which one of the bell shape is correct if the probability given is 0.1151. So we know that the total area under the curve is 1. So half of it is going to be 0.5. But since we have 0.1151 means the shaded region is very small. So the left side is incorrect because here we have a very large shaded region not tally with the probability given. So the correct bell shape is the right one. Thus, proceed to the third step, which we need to identify whether we need to put 1 minus or not. So since we didn't shaded the middle side of our bell shape, so doesn't need to put 1 minus. Just simply take z greater than or put it equal, since we have equal in the question, and then take the value here, m minus 4 divided by 3, which will give us the probability of 0.1151. Then move on to the last step is to take a look at the standard normal table, but we need to find the probability, the value of z that will give us the probability of 0.1151. So take a look at the standard normal table. Find here for the value of 0.1151, which is here. So the value is z greater than 1.20. 1.20. So from the normal table, from the standard normal table, we could see that z greater than equal to 1.20 will give us the probability of 0.1151. And then we compare m minus 4 over 3 is equal to 1.20, and then rearrange until we get the value of m, which is 7.6. J, the value of n if probability x less than n equal to 0.0582. As usual, for normal distribution, we have 4 different steps. The first one is to standardize. Second step, sketch the bell shape. But since our z is unknown, I'm going to sketch 2 different bell shape to check which one is the correct one. The shaded region would be on the left side of the z, of the value of z, because we have z less than. So to the left, and then check which of the shaded region tally with the probability given. Since we are given 0.0582, which is very small, not even half, so the correct one is the left one. The right one is the right one is incorrect. And then we proceed to the third step, which is to identify whether we need to put 1 minus or not. So in this case, since we didn't shade the middle part of our bell shape, we didn't need to put 1 minus. Instead, we just take probability of z greater than this value here, and minus 4 over 3. But then, we need to remember that the value of z on the left side is negative. So we need to put negative here. Right? And then we proceed to the next step, which is to take a look at the standard normal table. Take a look at the normal table to find the probability given, 0.0582. 0.0582. So 0.0582, 0.0582 should be somewhere here. So the value is 1.5 for the first decimal, and then the second decimal is 0.07. So 1.57 from the normal table. Probability for Z greater than 1.57 is equal to 0.0582. I didn't put equal sign here because the question didn't have the equal sign, so I'm just going to follow the question. Right, and then the last part is to compare. So we have negative of n minus 4 over 3 and make it equal to 1.57. Rearrange until we get the value of n. So n is equal to negative 0.71. Example 17. The lifespan of a calculator has a normal distribution with a mean of 60 months and a standard deviation of 5 months. It means that we can denote it as x tilde n for normal. Put our mu, which is 60, and variance. Variance or sigma square is equal to 5 square. Next, the question is, if a calculator is randomly selected, find the probability that the calculator has a lifespan of more than 70 months. So more than 70 months means x greater than 70. So in order to find the probability for normal distribution, we need to follow the 4 steps that I already mentioned earlier. So the first step is to standardize, change from x to z. 70 minus our mu and divide by our sigma, standard deviation. Calculate. This equal to 2. The second step is to sketch the bell shape. Since our z is positive, it's going to be on the right side. And then the shaded region for z greater than is going to the right. That is our shaded region. And then the third step is to identify whether we need to put 1 minus or not. But for this example, we doesn't need to put 1 minus since we didn't shade the middle part of our bell shape. So it's just going to be probability z greater than this value. And then the last step is to take a look at the standard normal table. So if you take a look at the standard normal table, you're going to get the answer is 0.0228. That is for the first one. The second one, we like to find the probability for the calculator has a lifespan of between 4 years and 6 years. First of all, we need to change from years to months since our mu is given in terms of months. So change from years to months. 4 years means 48 months, whereas 6 years means 72 months. So for the first step is to standardize. And calculate. Second step, bell shape. Negative 2.4 is on the left side. Positive 2.4 on the right side. So the shaded region will look like this. Proceed to the third step, which is to identify whether we need to put 1 minus or not. Since we shade the middle part of our bell shape, we need to put it 1 minus. And since you have two values of z, we need to minus 2 probability here. So the first one minus with 2.4, and then for the second one also 2.4. Or we can just simply write it as 2 multiplied by probability z greater than 2.4. Then the last step, to take a look at the standard normal table for z greater than 2.4, which will give us the value of 0.0082. Calculate, we're going to get 0.9836. A calculator that starts malfunctioning less than 3 half years of the purchase will be replaced by a new one. Find the percentage of calculators that are expected to be replaced. Since we know that if the calculator is still under the warranty, we may be able to replace it with the new one. So less than 3 half years means probability, we need to find the probability that x less than 3 half years. But we need to change from years to month since the mean is given in months. So 3 half, 3.5 multiplied by 12, so we have 42 months. And then we need to follow the same 4 steps in order to find the probability for normal distribution. So the first step is to standardize as usual. Minus mu divided by our sigma. Calculate. We're going to get negative 3.6. The second step, bell shape. Negative 3.6 on the left side, and then the shaded region for z less than going to the left. This is our shaded region. For the third step, we need to identify whether we need to put 1 minus or not. But since we didn't shade the middle part of our bell shape, we doesn't need to put 1 minus. So we just find the probability for z greater than this value here. Just make it positive. And then the last step, take a look at the standard normal table. We're going to get the value of 0.00016. Right? And then, since we would like to find the percentage of the calculators that are expected to be replaced, so we're going to calculate 0.00016 divided by 1, the total number of probability is 1, and then multiply by 100. We're going to have 0.016% of the calculators that are expected to be replaced. Example 18. A certain type of cabbage has a mass which is normally distributed with mean 1.2 kg and standard deviation 0.2 kg. X tilde normal because it follow normal distribution. Our mu or mean is 1.2 and variance is 0.2 square. A. In a representative batch of 1000 cabbage, calculate an estimate of how many will have mass greater than 0.9 kilogram. So we need to find the probability that the mass of the cabbage is greater than 0.9. As usual, follow the 4 steps. The first one is to standardize, change it from x to z. Minus mu over sigma, which is the standard deviation. Calculate. Give your answer maximum 2 decimal places. And then the second step is to sketch the bell shape. Negative on the left. Z greater than means the shaded region are going to the right. And then the third step is to identify whether we need to put 1 minus or not. Since we shade the middle part of our bell shape, we need to put 1 minus and then probability Z greater than this value here, 1.5. And then the last step, take a look at the standard normal table, and we're going to get 0.0668, which will give us 0.9832. And the last one, since we need to find the number of cabbage out of 1000, so we just calculate the probability here, multiply by 1000, which would give us 9. I'm sorry, here it's supposed to be 9332. 9332. So when we multiply by 1000, we're going to have 933.2, but we know that cabbage cannot be in point, so it's approximately 933 cabbage. A farmer rejects 5% of a large quantity of cabbage because they are underweight. Calculate the minimum acceptable weight of a cabbage. So the farmer will reject 5% if the cabbage are underweight. So let's say the minimum acceptable weight, we write it as W, for example. So if the mass of cabbage is less than W, the farmer are going to reject it. So the probability for a farmer to reject the cabbage is 5%, or in point it is 0.05. Right, and then as usual, the first step is to standardize. Second step is to sketch the bell shape, but since our Z is unknown, I would prefer to sketch two bell shape and to check whether the value of Z lies on the negative side or on the positive side. So the value of Z is W minus 1.2 divided by 0.2, and here is also the same. So the shaded region, it is for Z less than, which means to the left. Next, we check the shaded region, the probability that is tally with the shaded region. 0.05 is a very small number of probability, so this one is incorrect. So the correct bell shape shows that our Z is actually negative. It lies on the negative side. Next, proceed to the third step, which is to identify whether we need to put 1 minus or not. And since we didn't shaded the middle part of our bell shape, we doesn't need to put 1 minus, so we just have to put Z greater than this value here, equal to 0.05. But then, since our Z lies on the negative side, we need to multiply it with negative number. And for the last step, take a look at the standard normal table to find the value of Z when the probability is 0.05. So from the normal distribution table, find the value of Z that will give us probability 0.05. So take a look here, 0.05. We don't have exactly 0.05. It's either 0.0505 or 0.0493. So we take the closest one. So the closest one to 0.05 is this one, because the difference is only 0.0005. The other one, the difference is 0.0007. So here the value of Z is 1.6 and the second decimal 4, so 1.64. Probability of Z greater than 1.64 will give us a probability of 0.05, and then we just compare. For the last step, take this one, negative W minus 1.2 divided by 0.2 is equal to 1.64. Rearrange until we get the answer for W. So W is equal to 0.872. Example 19. In a certain public examination, the mathematics marks are normally distributed with a mean of 75 marks and a standard deviation of 10 marks. So X tilde normal 75 10 square. A. If candidates with marks at least 60 will pass the examination, then what is the probability that from 3 candidates selected at random, only 2 of the candidates pass the examination? So first of all, we need to find the probability that at least 60 will pass the examination. Marks at least 60 will pass the examination, which means we need to find the probability for X greater than 60. As usual, the first step is to standardize. Put it over sigma. Calculate maximum 2 decimal places. Negative 1.5. Second step, bell shape. Since our Z is negative, on the left, Z greater than, shaded region goes to the right. Next, identify whether we need to put 1 minus or not. Since we shade the middle region of our bell shape, we need to put it 1 minus and Z greater than this value here. Then the last step, take a look at the standard normal table, 1.5. Standard normal table, 1.5 here. 1.5 for the second decimal is 0. So 1.50, the value is 0.0668. Which will give us the value of 0.9332. That's for the first part, to find the probability that candidates with marks at least 60 will pass the examination. And then for the second part of the question, this is actually the binomial distribution out of 3 candidates, which means X distributed by binomial, distributed binomially, and P. So N is 3, the total of 3 candidates, and then we would like to find the probability that only 2 of the candidates pass. So we'd like to find the probability that X equal to 2. So the probability that will be passed, the probability for the candidates to pass the examination is 0.9332. And then as usual, as we already learned earlier, to find the probability that X equal to 2 for binomial distribution, we can just use the formula NCX P to the power of X Q to the power of N minus X, which is 3C2 P to the power of X, and then Q, which is 1 minus 0.9332 to the power of 3 minus 2, which is 1. Calculate, and you get the answer is 0.1745. B. If the examination syndicate intends to pass 70% of the candidates taking the examination, find the lowest passing mark. For example, we assume the lowest passing mark is equal to L. So in order to pass, the candidate need to get the marks greater than or equal to M. And then the probability of the candidates that we pass is 70%, which is 0.7 in point. As usual, follow the 4 step, standardize, bell shape. But since we don't know whether Z is negative or positive, need to sketch 2 bell shapes. Shaded region for Z greater than equal is going to the right. Right? And then 0.7 is a big probability. So it is not logic for this one. The logic one is that Z lies on the negative side. So we proceed to the third step. Need to identify whether we need to put 1 minus or not. Since we shade the middle part of our bell shape, we need to put it 1 minus and then probability Z greater than. But I'm going to put equal sign because the question has equal sign in here. So Z greater than equal to this value M minus 75 divided by 10. But since our Z lies on the negative side, we need to multiply it by a negative number. And the probability is going to be, the probability is equal to 0.7. And then rearrange until we get the probability left on the left side. 0.3. And then proceed to the third step is to find the value of Z that will give us probability 0.3. So take a look at the standard normal table and find 0.3 in here. So 0.3, we doesn't have the exact value for 0.3. We have 0.3015 and 0.2981. So we need to find the closest one to 0.3, which is, I guess, this one. The difference of this one with 0.3 is 0.0015. But for this one, the difference with 0.3 is 0.0015. So here is the closest one, which is the value is Z greater than 0.52. From the standard normal table, we could see that the probability for Z greater than 0.52 will give us the probability of 0.3. And then you just compare the value here. Negative M minus 75 divided by 10 is equal to 0.52. And then rearrange until we get the value of M, which is 69.8. Example 20. If the random variable X has a normal distribution with mean 45 and variance sigma squared, and we're given the probability for X greater than 51 is 0.288, find the value of sigma. So first of all, as usual, we're already given the probability, so we need to standardize. Okay, divided by standard deviation, which is sigma. And then bell shape, but since our Z is unknown, we need to sketch 2 bell shape to check whether Z lies on the positive side or on the negative side. So the shaded region, since we would like to find the probability Z greater than, so the shaded region are going to the right. Our probability is less than 0.5. It means it's a very small probability. So the suitable one, the right one. This one is not logic. The third step, to find whether we need to put 1 minus or not. But since we didn't shade the middle part of our bell shape, we doesn't need to put 1 minus. So we just take probability Z greater than this value here, which is equal to 0.288. We doesn't need to multiply it with negative number because our Z lies on the positive side. So doesn't need to put negative. Then for the last step, take a look at the standard normal table to find the value of Z that will give us probability 0.288. From the standard normal table, find the probability of Z that will give you 0.288. Zero point two eight eight. Here, 0.2877. So this is the closest one to 0.288. So the value of Z is 0.56. 0.56. Right? Then lastly, compare 51 minus 45 divided by sigma is equal to 0.56. Rearrange until we get the value of sigma is 10.71. Example 21. The masses of textbooks in a school bag of a student follow a normal distribution with mean mu standard deviation sigma. 10% of the books have masses exceeding 900 gram. It means that probability X exceed 900 gram is equal to 10%, which is in 0.1. And for the other one, 5% have masses less than 750 gram. So probability for X less than 750 is equal to 5%, which is 0.05. Find the value of mu and sigma. So we need to solve this equation simultaneously in order to find the value of mu and sigma. Two unknown, so we must have two equations. So for the first one, as usual, we're going to standardize. But since our mu is unknown, sigma is also unknown, just put it like that. And the second step is to sketch the bell shape and to check which one is the logic probability for the shaded region. So the shaded region is going to be on the right, Z greater than, so going to the right. And then the bell shape that is suitable with 0.1 probability, which is very small, is actually the right one. Next, proceed with the third step, is to identify whether we need to put 1 minus or not. But since we didn't shade the middle part of our bell shape, doesn't need to put 1 minus. It's just going to be Z greater than this value here, equal to 0.1. Doesn't need to multiply it with negative since our Z lies on the positive side. Lastly, take a look at the standard normal table to find the value of Z that will give us the probability of 0.1. Standard normal table. Find the probability of 0.1 or the closest one to 0.1. So I guess the closest to 0.1, it's either here 0.1003 or 0.0985. So the closest one is obviously 0.1003 because the difference is 0.0003. So the value of Z is 1.2, and then for the second decimal is 8. So 1.28. 1.28. Lastly, compare 900 minus mu divided by sigma equal to 1.28. So here is our first equation. We can just simplify it into this. I'm going to make mu as a subject. 900 minus 1.28 sigma. That is our first equation. And then we proceed with the second probability given and do the same thing. Standardize. Bell shape. Shaded region, Z less than, going to the left, into the left. The probability is very small, so the logic one is on the negative side. Doesn't need to put 1 minus, so it's just Z greater than this value here. But since our Z lies on the negative side, we need to multiply it with negative number. Lastly, take a look at the standard normal table. Find the value of Z that will give us probability 0.05. So if you take a look at the normal table, you're going to get the value of Z is actually 1.64. Then compare negative, (1.64), then simplify until we get the answer. I substitute the first equation into the second one. After that, you're going to get the value of sigma. If you solve it, you're going to get the value of sigma is 51.37 and mu is equal to 834.25. So, mu and sigma, we already find the value for mu and sigma as what the question is.